I'm going to go through two additional examples for finding derivatives of exponential functions, just in case you wanted a little bit more practice. Okay, so we're going to go through two additional examples that weren't in the previous video. Okay, so for this first one, we have y equals e to the 4x minus 5 all over e to the 3x. And you could go through and do the quotient rule with this, with the low d high minus high d low over low squared, but that's actually the more complicated way to do that. So what we really want to do is we want to find a way to rewrite this function. There's two ways to do that. Option one is take the expression in the denominator and write it with a negative exponent instead, and then multiply it, because I'm undoing division, the opposite of that is multiplication. Multiply it by the numerator. All right. So I'd say about half, if not more of you, were using that, rewriting with a negative exponent and distributing. And if you go through and do that, you would then be adding exponents on the e's. So you would have e to the 1x minus 5e to the negative 3x, okay? Which will allow us to avoid, again, using the quotient rule, and also avoid using the product rule, because it's simplified down to two individual terms, okay? That's one way to rewrite. You could also just go through, if you wanted to, and you could say that this is y equals e to the 4x over e to the 3x. You could do out the division, minus 5 over e to the 3x. And then subtracting exponents here, you would get e to the x. Rewriting with a negative exponent, oops, sorry, I wrote an equal sign there, that was silly, minus 5e to the negative 3x, okay? So either way you look at it, whether you choose to do it the way I did in blue or the way I did it in green, either way you're going to get to the same original function, okay? So these are both original functions. Now we want to use that and we want to find the derivative, okay? All right, so let's have a little space here, work on the derivative. So the derivative, y prime, or dy dx, whichever notation you prefer at this point, they're both fine. All right, the derivative of e to the x is exactly e to the x. It doesn't change, all right? I know it's weird, but that's what it is. And then the next part, the derivative of e to the negative 3x is itself e to the negative 3x times the derivative of the exponent. The derivative of negative 3x is negative 3, okay? So our derivative here is e to the x. The double negative gives us plus 15 e to the negative 3x. And you can leave, this is the one and only time that you can leave a negative exponent in your answer, okay? So this is what we're looking at for a final answer here. Negative exponents are okay to leave on an exponential. Okay, so that's example one. I'm going to go through one more. So for problem number 2, we've got y equals a natural log of an exponential. So this is actually going to be a natural log derivative first and foremost. So there's no way for me to expand this because there is not a product on the inside or a quotient on the inside or an exponent that applies to the whole thing, okay? Now if there were, say, an exponent here, that exponent could be pulled out in front, but we don't need to do that because there is no exponent in this problem. I just introduced it to give you that reminder. So there's no way to expand this, okay? So this is first and foremost a natural log function, so I need to remember how do I do the derivative of a natural log. So again, y prime or dy dx. Again, you don't need both notations, just one or the other. The derivative of a natural log, so the derivative of a natural log of u is 1 over u times the derivative of u, okay? So this is 1 over the inside, e to the x squared plus 5 times the derivative of e to the x squared plus 5. Now the derivative of e to the x squared is itself times the derivative of the exponent. The derivative of x squared is 2x. And then the derivative of 5 is 0. So you can write the plus 0. We don't really need it there, though, because adding 0 doesn't change anything, okay? And now we need to get this into one rational expression. Okay, so the 2x and the e to the x squared go up top. Put the polynomial piece first and the exponential piece at the end. All right, and then the bottom we have e to the x squared plus 5. So that's the derivative of this natural log function. And those are your two additional examples.